idea for Cameron was, and the reason why I picked Cameron as the name is because of his the biggest part of the project was really about the cameras and bringing in imaging. The whole idea started out with trying to come up with an idea that I could utilize Edison in that would, kind of take use some of the performance that Edison had. So the idea was to have a device that looks at someone who's standing in front of it and mimics the clothing. So like he would look at your shirt or wherever he's looking, wherever his eyes are looking, and he would mimic that color. So he's got some systems that aren't really working right now, but you can see how the LEDs are RGB LEDs. He's got some LEDs where all of the colors are turned on, and then some are just a few of the colors, and you can see they change a little bit. But ideally, when it's working correctly, he would, every couple of seconds, he would look at something and you might see black and then all the lights would go off, or he might see a blue shirt and all the LEDs would light up blue as opposed to bluish white or whatever. So it's kind of it.
So the LED changes with whatever the camouflage colors.
Right. So that's where the chameleon part of it came in, color changing and cameras, and so it all kind of fit together.
Thank you.
Anouk Whipwrecht, a fashion tech designer from the Netherlands.
Okay.
And she had a vision behind the Synapse dress that you would have the dress act on the wearer's behalf. So almost like you have a sixth sense. It's trying to read the things that are in your mind. This is the dress itself. It's 3D printed from TPU. And it actually incorporates 120 watts of high voltage lights. And the system is driven by EEG, EKG.
Yeah, right, EKG.
And proximity sensors. So there are 5 different modes that the wearer can make happen by voice. She'll ask for a mode, and it'll go into a mode that, for instance, lets the EEG drive taking a photograph. So when she reaches a level of 80% concentration, it'll snap a photograph. Yeah. Or with the proximity sensor, when somebody moves a little too close to her, these lights climb up and they go up all the way to the shoulders. 120 watts of high-power LEDs will basically tell you to back up.
So what is the purpose of this?
This is really an exploration in materials and an exploration in a concept of sort of extending what a garment can do on your behalf. Extending the notion that your garment becomes almost like instinct.
So the sensors in there.
Yeah. So it acts on your behalf, and some of this also plays with the notion of personal data. So all of the EEG and EKG and the proximities that are being captured, it actually is output via Wi-Fi on Edison. We actually have, I don't have it down here, they're actually have it up in the room working on it, but it outputs it via Wi-Fi to a web server, and so you can see the more clinical side that looks like personal data you're accustomed to seeing. So like the lines and the beeps and stuff. These are some of her previous designs. She often plays with the ideas of personal space and the...
So is she going to be using this in the gaming industry, or what industry is she?
Well,
medical industry?
It is fashion tech.
Oh, it's fashion?
It's actually called fashion tech. So this is fashion. The dress is here. The model is getting ready right now.
I think I saw her on the...
we were on stage at Mike Bell's thing.
Yes.
Yeah, pretty fabulous.
She designed it. How amazing. So she used the Edison...
Yep, it's Edison driven.
Wow.
Isn't that crazy? The Edison lives under the bodice of the dress.
Is that what the lights are? When you see the sensors light up?
So the lights are driven by the sensors, yeah. We had to do a demo mode for on stage, which basically showed what happened in the proximity one. So if you got too close, it would climb up and get really bright. And think about that. If you can start making your clothing have the reactions that you're having, you're probably thinking, if I get here, it's a little too close. And what if
it'll tell you.
Yeah, that's right.
Whoa.
And so it kind of expresses what you're thinking or expresses what you're feeling without you doing anything. So your clothing becomes clothing and the technology becomes the medium of communication. It's pretty funky.
It's a safety thing too.
Exactly. Imagine if we could do that, or you could have a way to communicate I am comfortable, come closer. I mean, really, you've heard of like bespoke fashion, right? This becomes bespoke electronic couture. I mean, you could actually identify what you want your dress to say about you and code it.
That is so
Awesome
amazing.
It is. When you start thinking about it, about more broadly, the vision that it sets, you're like, wow, my clothing could be communicating my what I'm feeling, what I'm sensing, my sense of stress, my sense of excitement. It could all be output in a different way. Because we always think about it in such a clinical way, you know, about what the beeps and the trackers and all that stuff look like. But this is a little bit deeper.
If you wanna like test press the dress, like is it working or not, then you will say exercise. So it will make the all ending pose for a minute or for a second. And if you want to click the picture, you will say portrait. So it will just have some different pattern so that you can click the picture. And if you want to take a video animation, so we'll have the animated patterns of the lights continuously. You'll say embody.
Okay.
And if you want to enable the mind sense, you'll say muse. It will enable the mind sensors, EEG sensors.
Wow. So it's all sensor based.
Yeah, it's all sensor based.
Thank you.
And if you want to look for the proximity to just see okay, how far everyone is, you'll say the speculate. And it will enable the proximity sensor. Which is
And she like whispers into her.
Yeah.
There is the lovely Whitney.
Oh, I gotta have a picture of her.
We went ahead and created for the Edison a series of boards that stack underneath the Edison, stack one atop the other, so that you can add a bunch of hardware functionality to your Edison system without having to sacrifice the small footprint that the Edison naturally brings to the application. If you look comparatively to the Arduino solution, you can see just how much smaller what it is that we offer is. And at the moment we have 14 designs that we offer. We've got just sort of a simple prototyping design. We offer a small display with a couple of buttons. We've got pulse width modulation, battery and charger, accelerometer, gyroscope, magnetometer, IMU, H-bridge, console connection with an USB on-the-go connection, analog input, I2C output, servo or micro SD. This actually adds an Arduino, an actual Arduino board in the Pro Micro or Pro Mini form factor, and then this actually adds the connector that the Raspberry Pi has on it, so that you can.
So I've seen it all. I have a question on the Arduino board. What chip did you use?
It's an Atmega 328, so it's a standard, bog standard Arduino, original Arduino processor. So it can be programmed just like any other normal Arduino, and then you can interface to it through from the Edison. And if there's some I/O application or something that you really want to just offload to that, that allows you to do
It's
so.
on I2C.
So what is that?
So you can stack multiple
This is just a
servo
little
drivers.
robot that Casey put together, just as a good demonstration of what's possible. You can see our stack here. There's 4 servo motors, 4 drive motors. The drive motors are ganged, the servos are independent.
So you grab our servo.
And so we have control over, we can do self-writing, terrain adjustment, whatever we need on the robot. All of this is done with this little itty-bitty stack of Edison boards. Pulse width modulation, servo motor, there's an IMU in here, battery charger, and console connection.
Wow, amazing. Thank you so much.
Thank you very much.
Taken an Edison and launched it on a weather balloon up to 100,000 feet altitude here. At 100,000 feet, the balloon burst, and we managed to capture, using our onboard GoPro camera, the image of the balloon actually shattering and bursting in space.
Okay.
We were thrilled to capture that image. What this is the Edison module talking to 2 peripheral devices, a GPS module, which tells it at any given second where it's located and what altitude it is, and then an Iridium satellite transmitter, which relays that information every 3 minutes back to the ground station. And so if you look at this map here, what we're doing is, after we launch the balloon, we track its progress 3 minutes at a time. Each one of these little purple dots represents a 3-minute interval that the balloon has arrived at a different destination and altitude. So for instance, at this one, the balloon is at 27,000 meters, it's traveling 37 knots. It's actually quite close to the point where the balloon bursts, about right here. Comes plummeting back down to Earth, and when it gets to the ground, it tells us, hey, I'm on the ground, come pick me up. So we hop in our car, we come driving out, and we go collect the payload, which includes a GoPro camera, which for the entire 3-hour duration of the flight has been recording high-definition video of what it's like at 60, 70, 80, 90, and 100,000 feet. And we've gotten some fairly spectacular images. Of course, as I showed you, the image of at 100,000 feet of the balloon itself bursting.
That's great.
Project.
So I have a question.
Yeah.
What would be this good for? Is it good for storm chases or what this process would be great for?
The first and foremost, it's just outrageous fun.
Of course.
It's so much fun
I
to say,
love fun.
look what we did. We made this video of what the atmosphere looks like at 100,000 feet. But you know, there are applications. We want to launch it in a storm to see what it's like to be above a lightning storm at 100,000 feet. We want to gather weather data at 80,000, 90,000 feet and see if we can notice patterns in temperature and things. But like I said, it's mostly just outrageous fun. We can't wait to go home and launch some more.
Thank you.
Thank you so much.
This is a smart construction helmet that is used for workers in a building, in a construction or a mine. And the idea of this is to allow to detect 3 things. One is faults, strikes, and gases. So whenever it detects one of those events, it will send a notification into a web dashboard, and then a notification into a push notification, for example, to the cell phone of the supervisors of the construction or any people interested on, and so they are alerted and notified whenever an accident happens. That's the idea.
Thank you. Awesome.
So that is a simulation, for example, working with different helmets. So they provide a GPS location, and this is like the dashboard.
So this tells you if somebody's hurt or something's going wrong.
Yep.
Thank you. Right away.
Right away. And this is our first version of the product, and this is the second version, which is equivalent.
Thank you so much. So can you beat it up with the baseball bat?
Yep.
So I can see?
I'm gonna make first.
Go ahead. Thank you. That's what I want to see.
The first demo. I'm gonna put some gas on it, and we're going to see
Closer, maybe. Yeah.
We're going to see in a couple of seconds. So we have smoke in here. Detect some smoke, and if I also hit it, we have a strike.
Thank you.
Yeah. You notice the latitude, longitude here, and you're gonna see it here in Google Maps.
Okay. Thank you. So it's a tracking to see where someone is if they're hurt. It doesn't matter what happened, fire or
Whatever.
anything.
A fall or a strike. Yeah, and you receive a notification on your cell phone or your tablet or whatever. So maybe the paramedics receive the notification and they just run to see what happened.
So it's connected to the paramedics as well. So everybody gets to know.
For now,
If it's a national disaster, let's say it's a lot of people.
For now, it's an Android application. So who has the application, it will receive the notification in this case. But the idea in further versions is to have different kind of communications. So to alert maybe directly the medical people or another.
Thank you guys.
You're welcome.